short revision of the TFTP protocol. Then I will talk about the atftp, client and server. I will go a bit more into details of the TFTP protocol and show you some extensions to the protocol. And then I close with a security issue and a PCRE2 port. Okay, what's the trivial file transfer protocol about? It's a very old and very simple protocol. Whenever you happen to teach protocols, it's a very good start because it's really something where you can read the RFCs and you can understand them within a few hours or a weekend. And it's great to get an introduction into internet protocols and how they work. So it's very simple. The client sends a read request to the server, and the server then, the read requests contains more or less only the file the client wants to fetch. And then the server sends the first data block. The client answers with an acknowledgement when it receives this data block, and this happens back and forth, and in the end, when the last block of the file is sent, it's finished and it's done. Okay? As I said, the protocol is very old. It's more than 40 years by now. And after some time, people found an interesting bug in the protocol definition. And it really made it into some kind of human arts and culture. You may know a famous poem by Goethe, and the interesting thing is it's also in other cultures where there is a sorcerer's apprentice, and his master left the house, and he tries some spells, and he thinks, I'm powerful, I'm learning this magic stuff. And he starts to create a servant to fetch him water to take a bath. And this works pretty nice, and he feels even more powerful and even greater. But then he didn't remember the spell to stop this. Okay, and the bath gets full, and it's too much water, and this servant still carries more water from the river, and he doesn't know how to help himself, and he, with an axe, he hits the servant and smashed him into pieces. But then he suddenly had two servants, so these two pieces started carrying the water, and it all got worse and worse. And fortunately, his master comes home and he knows the spell, and he stopped all this chaos. And this is still today in today's language. If someone summons allies he can't control in politics or something, we still use this in German as die Geister, die ich rief, die werde ich nicht mehr los. I wrote it down in English translation. The spirits I summoned on, I now cannot get rid of them again. So maybe you also know this from your culture. Yeah, and something like that happened in this trivial file transfer protocol. Maybe I just go back. It happens when the acknowledgement is kind of delayed, and after some timeout, the server sends the data block again, and then this acknowledgement gets through, and it sends the same block again. So every block is sent twice by that time. And this doesn't stop anymore, because the client acknowledges every block it receives, even if it's the same block, even if it got the block twice, and the same on the server side. So this was a flaw in the protocol, and this has been fixed. And yeah, this is also in this second revision, 1992. And then another improvement was about 20 years after the first initial release of the protocol, an option extension. I will come to that later, and then some how you can use this option extension. And finally, and this is also going to be interesting soon, 2015, so not too far ago, it was a window size option introduced. So what implementations of a TFTP server do we know in the free software world? There is TFTPD minus HPA, very common, very popular TFTP server. Then atftpd, advanced TFTP server. That's what I'm mostly talking about. And you find also other places. This list is probably not a full list. DNS Mask has a TFTP server inside, and it's simple and easy to implement. So it's not. It's very. There are many implementations. Where do you use this protocol? For most of us, this will also be well known. Because of triviality, it's only used in the local area network usually. But it's sometimes very important there. Even it's getting kind of replaced by HTTP protocol. But the older machines or standard machines, they just can network boot, and they fetch some network boot program by TFTP, Pixie boot, and it's also used very much in embedded systems and flashing firmware on routers or firewalls, IP phones, and all that. Okay, so let's look a bit more into the atftpd. It was programmed about year 2000, and then soon after that it was also packaged in Debian, and then it had a long history. If you want, you can look that up in the Debian tracker. But this the maintenance kind of was slowed down, became less, and about a year ago, this bug, RC bug, occurred, was reported right in the freeze of the Bullseye release. And I thought, well, I'm using this packet. I want to have it in Bullseye. And it was just mostly the RC problem was mostly missing this dependency. But as you see there are other problems. And that's where I started looking into this package, and I first fixed the dependency with an NMU. But then I thought, well, this is an interesting package, and it's not too far, and even for a part-time programmer like me, I can maybe contribute a bit. And I set up a Salsa repository and brought everything up to date, clean up, and things like that. And then I happened to find this Sorcerer's Apprentice syndrome, and there were already patches upstream. The sources are still on SourceForge, which gives you a slight indication about the status of upstream maintenance or upstream activities. And I contacted upstream, and they were then committed, and all that went a bit further than it was before. Okay, then I'm coming to the window size extension. When I studied this protocol, I looked into the RFCs, and also, of course, in these TFTP option extensions. And there were four different options, and two of them were already implemented in atftp. The T size, this is the client, oh no, the client can show the server that it's interested in the total amount of data sent, so in the transfer size. And it can show this in the read request by setting like here, t size equals 0 in the read request, and then the server can send the total transfer size to the client. The block size is also quite useful because in the beginning the protocol just had a fixed data block. 512 bytes were sent with every data block, and of course you can standard Ethernet, you have a MTU of 1500, so maybe you want to increase that to need less, a smaller number of blocks. So the client can tell the server, this is the block size I'm interested in. Okay, then he can arrange for another timeout than the default. And the window size, which I got really interested in because it was not implemented yet. This works in the following way. And this is shown in this slide. Well, what makes this protocol small? For every data block, you need one round trip. Okay, you send the data block, you wait for the acknowledgement. So this is one round trip, and of course, this is very inefficient. It's very simple, very easy, but it's also very inefficient. And usually, you don't have, you're not losing many blocks. Okay, when I tested this on a school network, almost never a block is getting lost because, well, if the network has good bandwidth, then servers can cache a lot, and so you don't have these congestion problems, at least not in the network I tested. So the idea is not to send a single block, but send a series of blocks and then wait for the acknowledgement. Okay? So for example, here you say, oh, I'm fine with a window size of 4, and the server then acknowledges these options and then sends 4 data blocks, and then it starts waiting for the acknowledgement. And the client says, okay, I got the 4 blocks, I received the 4th block, and it again starts with the server sends again the next 4 blocks. And this makes it, of course, much more efficient, much more faster. Okay? When you look into the RFC, it's really also comprehensible and clear, and it's really simple and understandable, even without doing huge research on it. And there's also here on the right-hand side how much for this particular network where they tested it. You can see if you just send 2 blocks in one window, it's of course almost 2 times faster. And yeah, here is an example with Wireshark, window size 3. As I said, you send 3 blocks, then acknowledgement, next 3 blocks, acknowledgement, and until you've transferred the whole file. And window size 5 in the lower part, it happens the same. Is this implemented already anywhere? Yes, it is. I saw it in IPXE. They have a window size, the client has a window size of 4. Okay, so that's I think the only implementation I saw so far. Okay, the idea was maybe this can be added to atftp, and I looked into the source code, and the algorithm is really, it's not as simple as it's written there in the comment, but it gives you an idea. And I sat down and studied this and tried, and finally I really managed to implement that. And of course it gets more complicated when you look into the details. So for example, you can ask yourself, how do you handle loss of packages? Well, this is the crucial question, and there are different different ideas, and so this is interesting. And then next question is when you send the blocks within a window, do you have a delay between these blocks, or what is the best inter-packet delay within a window? And then is, of course, would be nice to have some kind of congestion control, so that maybe if you lose packages, you increase this delay or something like that. So that are interesting questions which are still not all perfectly solved and probably never will. I tried a bit with network emulation, and but it's also hard to judge, is this realistic? So this emulation I found was for wide area networks, and I played a bit, and kind of worked, but I'm not sure if it's the best or if it can still be improvements. Okay, while working on this, I tried some, I worked on the code, and suddenly I had a segmentation fault. And I first thought, oh shit, I made a mistake, and I checked and tried again, and oh no, it didn't went away. And then I fired up the debugger and really checked the variables and all that stuff, and then I found, oh no, it has been there before. Okay, and what was really interesting for me, that I really could see how this happened. The problem is that when you send this acknowledgement, this option acknowledgement, you use the same buffer which you use for the data later on. But this if you define a very small data block size, which is not useful probably in practice, this option acknowledgement can be larger than the block size, and you had this segmentation fault. And I reported this to the Debian security, and also contacted upstream and all that. It's not so terrible thing, because usually it's used in the LAN, it's not an internet service and things like that. And on this way, I also learned quite a lot. So finally, there turned up a bug, that there is an old Perl-compatible regular expression implemented in atftp, and maintainers are asked, or upstream is asked, to upgrade this to the latest Perl-compatible regular expression. And this was what I did in between Christmas and New Year's Eve this year, because upstream has only very little time. And this is out now, also a patch available, so I hope that it's all now up to date. So all in all, I just want to say it was a great journey, which started with this NMU, and I learned a lot, and I just wanted to give you a report about this, and show you some interesting things. At least for me, they were very interesting, and so in some sense, I want to encourage to do NMUs. Thank you.
Thanks, Andy, for this interesting presentation. I don't think we have time for questions right now, because we need to prepare the next talk. But I'm sure whoever wants to ask something can find Andy today anywhere on the venue.
Yeah, I will be here until early afternoon at least. So just if you have questions, just contact me.
Great. So we'll be back in 2 to 3 minutes.